as interesting as possible. Suppose you are at the airport and going on a nice vacation to Peru, and you get a message from the bank that, did you think about your pension? Yeah, I think when you are going on a wonderful vacation, you probably don't want to think about your pension, and a more appropriate message could be whether you have got right travel insurance for Peru or not. These kind of things happen quite regularly when we push all these emails, offers, alerts to our customers, because it takes very long time before we know what you are planning to do. And then the next action, which we would like to do, it takes some time to calculate that next action. And by the time you get it, the information is quite obsolete. Imagine that somebody spends $2,000 or euro from your debit card at 2 o'clock in the night. How soon a bank should come to know about it? Within 5 minutes, 1 day, 2 days? I think banks should come to know about it very quickly, because it could be a fraudulent transaction. So the moment you know that 5,000 euro have been spent from your debit card at 1 o'clock in the night, then they check with you. And suppose if you say that, well, I was flying to Sydney through Dubai airport, and I bought an expensive watch, that is okay, but you don't do that every day. Now, this is a big problem, because the systems which are there in the large banks, they are not capable of doing that because of the several problems due to data duplications, multiple layers, batches, and so on. So what you see is that in the banking industry, we are kind of astonished by the trends in e-commerce industry, in social media world, and so on, that how come these companies are able to do that? How come Netflix is able to give very accurate predictions about my movie preferences? How come the Google is going to present right ads and so on? So a couple of years back, our CIO said that we have to become predictive and real-time bank. And that's what I'm going to talk about, that how Hadoop and these technologies really helped us. My name is Anurag Srivastava. I work for ING Bank in Amsterdam. So I was trying to find some definition. I could not find a perfect one, so I tried to create one that I think for me, the predictive is something that when you send a message to the customer, it should not be an irritating or annoying message. So it should be relevant for the customer. And when we talk about real time, you should be able to respond to events as quickly as possible. And I have personally seen some very strange things happening, that when I lose my debit card and I call the call center of the bank, and they suddenly tell me that oh, by the way, you could be eligible for a wonderful saving product or something like that. So when I have lost my card, I want to get help about how to replace my card very quickly, and not about a new product. So what are the real problems, and how we can really solve them? Let's take a look at the data platform. And I think this picture might be very familiar to people who are not kind of new generation .com companies and so on, or social media companies. Because most of the data warehousing technology in the banks is old. And in our case, our data warehouse, the entire platform was built around 10 years back. And Oracle was very popular, and still it is. And we built it ground up. So we bought storage area network, high-speed network fabric, and AEX, and all kinds of things, and we built our data platform. And it was good, it was powerful. We could very quickly cater to different information needs of the bank. But what happened in that process, that whenever a value chain came to us, we just created a new data warehouse for them. So for example, facility management comes to you, then you say, okay, what information do you need? You pull those files, you set up a data warehouse for them. If somebody else comes to you, you again set up a new data warehouse for them, and so on. So that way, you created a very large set of data warehouses. We have 130. And if you also see that you need a DTAP for everything, then you end up with many, many Oracle instances and very complex ETL process, because many times those batches are interdependent and so on. And yeah, once ETL processes become very complex, if they break, it takes you a lot of time to debug them. And when ETL does not work, then on Monday morning at 10 o'clock, you get a call from your customer that that report is not there. Yeah. So so data silos, batch processing. And last thing that we have is that very limited analytics. So most of the analytics is done on the data at rest. Of course, if you count the delay in the batch processing, then data comes to your analytics platform after 1 to 2 days. You create segments, you run campaigns, and so on. So it's quite slow. So this problem we were aware of, and we were having a lot of issues with the growth of our data platform. And around 2 years back, we came to know about something called Netezza, a wonderful appliance, very fast. We did some kind of test on it, and we found that the queries that we were able to run on Oracle with quite slow performance, we could speed them up 20 to 60 times. It doesn't require a lot of maintenance. You have this wonderful black box concept from IBM. You buy the appliance, and then they take care of everything. And you can do a lot of consolidation. You don't have to worry about the indexes and so on. So it was a very good idea. And because Netezza is an enterprise product with the label from IBM, it was easy to get it accepted in our data center. But at the same time, we discovered that Netezza is a pretty expensive machine. The cost of a storage is around 15,000 euro per terabyte. And if you also count the cost of maintenance and all those kind of things into it, then it becomes something like 70,000 euro, up to 70,000 euro, depending upon how expensive your IT organization is. And also, what you see is that in the end, you have got a proprietary box. You don't know much about it. And the last thing is that because storage is very, very expensive, you need to know very well what you are going to store on Netezza. But last few years, we realized that the size of data is growing, and especially when more and more of our customers started using mobile banking channels, internet channels, and so on. So according to a rough estimate, we get around 1 terabyte of data per day. Now, if I start saving this 1 terabyte of data from mobile channels and web interfaces in Netezza, that will be a pretty expensive proposition. So last year, in March, we started to do something with Hadoop. I'm going to show you a picture that how we see data platform target architecture. I think this is not a very old picture. In fact, when I made this submission, even at that time, it was not very clear, and we're still in the journey. So we said that, well, we have got two kinds of systems that feed data to us. We have got enterprise systems. We have got external systems. Enterprise systems are, like savings, loans, mortgages, those kind of systems, master data management systems. External systems are like credit rating agencies. We even get weather information from some places, all those kind of things. We bring this information in a layer called a data overlay. We thought about this layer because this layer can really let us mask some kind of data if you really do not want it to be used for analytics and so on. Then you take that data, you put it in Hadoop. So I call it Hadoop Excel because we store everything from the bank in Hadoop. And once the data is there, then a part of data we can use for building the model, predictive analytics model. And for fast querying, we use Netezza. So a subset of data from Hadoop we bring to Netezza for querying. And on the top, we have got all kind of BI tools and applications. And here you should think about Cognos, business objects, R, and all these kind of things. Please don't take photos. This will change. Okay. So now, when you talk about Hadoop in a large bank, you have a lot of challenges. The first is that it is new technology, first mover disadvantage. Nobody really knows about it. People are quite well familiar with Oracle, MySQL, DB2, and Hadoop is new. So nobody really knows about it. Experienced people are hard to find in a traditional BI department, and that is the department that usually deals with data in a bank. The people are working on Oracle, SQL, and so on, and they don't have any experience on Hadoop. And given the Java lineage of Hadoop, it's very hard for people to learn these new technologies unless you really put effort into it. You also get confronted with a lot of attention and hype about Hadoop. And surprising thing is that Hadoop is a technology that finds a lot of mention in non-IT media, like Financial Times, Forbes magazine, and all those kind of things. So people think that this is some kind of like a silver bullet. We have it, and then we can solve a lot of problems, and we become greatest and the best. Then another question that you get confronted with in the bank is that, do we really have a big data problem? We are not Facebook. And that's also quite true, because in most of the discussions around Hadoop, they talk about data at petabyte scale and so on. So if you look at like information from enterprise systems, you're not talking about petabyte scale. The information is maybe 70 terabytes, 100 terabytes, not more than that, unless you also start counting the data which is coming from the channels, the click streams and so on. There's no clear leader, and generally the banks are quite used to buying the software from large enterprise software vendors, such as IBM, SAS, Teradata, and all these kind of places. And this means that even in the procurement department, it's hard to get purchase order approved because the Hadoop vendor does not have long enough credit history. This company exists for 1 year. And yeah, that doesn't work in our system. Also, the community, Hadoop community is open source and Java driven. And if things are open source, then people are always worried about the security risks related to security and so on. The second set of the challenges, they come when you have to deal with the IT organizations of the bank. With IT organization, I mean that the infra organization, the people who really run the servers, data centers, switches, and so on. Now, you take your credit card and you can set up a Hadoop cluster on Amazon. That's very easy, but that's not possible in a bank. We want to keep data within the bank. Now, here you have to deal with the infra organization. Now, the infra organizations are very much geared towards high-end hardware. So they talk in terms of IBM P-Series, HP non-stop. And then you go there and you say that, well, I want to buy some cheap commodity hardware and I want to put it in the data center. Then their worry is that, is it going to catch fire? Is it going to shut down my network? What's going to happen with my AC capacity? So you can get all kind of questions from them. Data centers have been virtualized. So there's no concept that I want to have a machine with raw storage on it. It's all virtual, and that you have to use. That's their standard offering. And they talk in terms of SAN, storage area networks. And the last thing which they have is that the model of shared services. So when you talk about things like monitoring of your infrastructure, the build services, and all these kind of things, they're all shared services in a bank. So that means the guy who is sitting in the center where they monitor the services, he just knows one interface and he can just see all the incidents there. So if your software requires different kind of interface, that means they have to train additional people, they have to buy additional set of software, they have to do lifecycle management on it, and that means this becomes very expensive. So now what we did that last year when we started with Hadoop, we had absolutely no clue. And this is what we wanted to do. That was March last year. And we said, okay, let's play with Hadoop. So unlike other programs where we get the big funding in the bank and all that, we did not have any big funding. We had a very small budget. And we said, let's play with Hadoop. Yeah. But after that, picture became quite clear, how it is going to develop further. Then we said, okay, let's build a predictive analytics lab with Hadoop. And then the third step is that let's build a complete production system with Hadoop. So if you look at our journey, now I can say that this is how our journey looks like. In March last year, we had no clue. We were just building a play environment for Hadoop. Now, what we did in the play area, our goal was that we wanted to quickly learn about Hadoop, get something, install Hadoop on it, and play with it, create some interest and awareness in the organization. And what we did here, that we found some recycled blades somewhere in an isolated network in the test area. We set up Hadoop cluster. We did just one-time data load. no ETL, nothing, just load the data, put R on it, put Hive on it, and ask a small team to start working on it. So they started doing all these experiments, and we just took what was available, what was recommended, we just put it on this cluster, and it started working. Now, this became quite successful, and it got a lot of attention. So people said, well, why don't we put more people in this cluster? More teams, more analysts, and so on. But this cluster was not designed like that. It has very little memory. And it was not monitored. So that means if a server failed, then we had to discover on our own and call somebody. He will come and fix it, and so on. So we said, no, we have to build a new environment, and this environment will be called Predictive Analytics Lab. Now, here we had two goals. We wanted to make sure that we provide capability to build predictive models on Hadoop. So that means we have a team of data scientists. These people get access to data, and they can build all kinds of models. Second is that we wanted to make sure that this environment is secure. We can do regular data uploads, data loads on it. We can refresh the data quite regularly. It's a monitored environment. In a bank, the monitoring of the infra happens at two levels. You monitor infra, and you also monitor applications. For example, if you try to log on to some application and login fails thrice, some kind of alert is generated, and people get telephones and all those kind of things. So now what we want to do here is that we wanted to build a new Hadoop cluster with brand new hardware. We had to install it in a data center, not in a test area somewhere in the isolation. It has to be secure and monitored. And at this time, we decided to choose HDP 2.0, Hortonworks Data Platform 2.0. Now, this is where we are at this moment in the bank. Now, the implementation of this environment, we got a lot of challenges. Because one of the challenges that when you bring data from different sources in one database, then the risk rating of this data really goes high. So you have to take all kinds of measures to really prevent that this data does not get leaked. It's used in a proper way. So we had around 6 months time available to do this. So we agreed upon having a kind of strong parameter security for Hadoop. And we did this with the help of firewalls because we could not find any nice software solution for that. We had to implement multi-factor authentication. So this was one of the requirements which we are still busy with at this moment. Then infra people said that, well, this whole Hadoop thing is so scary that you cannot directly connect to Hadoop, so we'll provide you a Citrix server. This will work as a kind of stepping stone. So with the help of your corporate authorizations, you come to Citrix server. From there, you open sessions to your Hadoop cluster. Then you can start doing something over there. Then what we also did that we connected this cluster with our enterprise repository. So what happens that in Hadoop environment, you have the updates, upgrades, and so on, and all those jar files, they are pulled from the internet. But in a bank, you cannot just pull file from the internet and install them in your Hadoop environment. So we have got our own secure repository. That repository downloads all those jar files from internet. Then they are scanned for malware and trojans and those kind of things. Then it is available for our Hadoop cluster to run. And of course, we implemented monitoring for various kind of events. The monitoring of events takes place in our shared service center in Poland. So all these events, they go to Poland, and they can monitor this cluster. Hardware side, also we had some serious challenges. When you talk about cheap commodity hardware, just those people, they don't like that idea. They might say that, well, fine, we will do that. But that means you have to really go through a very, very extensive, complex certification process in which they really stress test your server. Maybe they try to drop it from 3 floors or whatever, something like that. And they just want to make sure that this is the right kind of hardware. Also, in the data centers, the deployment of operating systems is highly automated. And they can do this kind of automated deployments on virtual machines. So if you say that I want to run Hadoop on bare metal, so just take bare metal, install Red Hat on it, and then run Hadoop, that's not possible. So we settled upon some kind of like hybrid model. We said that, well, you create a little VM on the top of hardware and then deploy Red Hat on it, and then Hadoop on it. So we did not create like a full virtualized cluster, but every cluster has got its own virtualization layer and then Redis on it. And this way, they could roll out this pretty quickly. And so in the end, we had to make a compromise between the cost and what data center standards are. So we did not choose very high-end hardware, but we chose something which was recommended by our infra team. And this was based upon the HP 4540 series. And it's a 18 nodes cluster with, and one node of this cluster costs something like 16,000 euro, which is pretty high by Hadoop standards. But you could get it implemented pretty quickly in a data center, and then you don't have risk of fire or AC or those kind of problems. Then automated provisioning of Hadoop. At ING, we are quite fanatic about the automation. And we really want to automate everything, the deployment, the provisioning, everything we would like to automate. So when we saw that we have to create these 18-node cluster, then we made sure that we also have automated deployment in place using Ansible. This was also a kind of a departure from our corporate standards because the corporate standard is Nolio. But Ansible and Hadoop deployment works very well, so we used that. We used Ambari for monitoring the cluster internally. And we found that it was pretty easy to do. We saw a wonderful demo of that, and I think it was excellent. And I would always recommend that if you are doing it, automate things right from the day one. Then the last challenge was that the rapid pace of innovation. What you see is that the banks are not really used to this pace of innovation. We bought software from enterprise software vendors, and they come up with a release once in a year. And you know very well that what's going to be there in the release. Now here what was happening that every quarter we start talking about new animals, new terms, and all those kind of things. And that really confused people that what's happening. So when we were building our cluster, we started doing this project in October last year. And then at that time, nobody knew about Spark, Accumulo, Falcon, and all these names popped up. But we said, okay, let's not do that. Let's stick to the basic stack. And once this is implemented, then we'll move to the next step. But you really see that though our solution delivery process is based upon Agile and Scrum, the infra processes are very much a waterfall. So the moment you talk about new technology, new tool, then it creates a big pause in the whole process. So you just keep quiet and you say, okay, let's carry on. The another discussion is that there are a number of distributions to choose from. And here also, if you tell in large enterprise that you are going to put entire data of the bank in a software which has been built by the company that is in existence since past 2 years, 3 years, then people get a little bit scared. And again, the people get tendency to use enterprise stack which is certified by the enterprise software vendors. So we still said that, well, we are going to go for this choice. This is the best choice. And so far, this has really worked. So what we got in the end, this is our Predictive Analytics Lab. Now, if you see here that so this is my Hadoop cluster, and I have got 18 nodes here. This is my stepping stone based upon Citrix. This is the perimeter security. It has been completely protected with the help of firewalls. And this side is my shared services related to the Git, libraries, build tools, and all that is located here. We pull the jar files from internet. They come here. They get screened. Then only they get installed here in Hadoop. We have got SMTP relay to send the messages about build success, build failure, and those kind of things. And here we have got the monitoring services, which are located in Poland. And from here, we pull the data in batches. So still, we are not doing these things real time because this is a lab. So we can refresh data once in a day, once in a week. That's quite OK. But when we go into production, then we have to think about different solution. One thing which I don't have here in this picture is the connection with our corporate directory services. So anybody who tries to log on to this Hadoop cluster, first they get authenticated with our corporate LDAP server, and then they come here. Here you have got a set of data scientists and data engineers. And this is how our team really looks like. We use Scrum, and we have a Scrum team of 9 to 10 members. And team, we have got data scientists and data engineers and a product owner. We have demos every 3 weeks. Whatever we have done, we demonstrate that. And this is what we have got in the lab environment. Now, this is the very, very minimal stack. We have got HDP 2.0, we have got Hive, we have got Ambari Ansible, RStudio, Hue, and H Catalog. So this is the minimum stack we have created. Of course, as we move further, we'll try things like Spark and all kind of ML base and all these new innovations that we see in this Hadoop community. So now, so far our journey has been that we started from play area, we went to Predictive Analytics Lab. And when we were building the Predictive Analytics Lab, even at that time, we did not realize that the production, bringing Hadoop in production is going to be a different problem in itself. Because what happened that when we were setting up Predictive Analytics Lab, because of all the concerns related to security, we were told that you can only build predictive models in this lab, but you cannot get data out of it. So we have data in it, we can build the models, but if we want to run this model, then we have to find some kind of production environment, which we don't have. So this environment we have to build, and we are now in the process of starting with that because Predictive Analytics Lab is almost ready, and now we have to move on to the next step. Now, the production system, if you see that this is a quite problem of different proportions, because in the lab, data doesn't go out. A small group of data scientists works on it, maybe 40 people, maybe 50 people at the max. Excuse me. And it's pretty much contained. When you go into production, then you have to cater to the diverse information needs of your business. When 1,000 people work on Hadoop, then you have a lot of other questions that how are you going to secure the different part of data? Also in the production environment, you should be able to deploy the models that have been built in the Predictive Analytics Lab. And also, one of the things we see about Hadoop is that it can save us a lot of storage cost, but it should not mean that the reliability and availability of our data really goes down. And storage area networks, they are pretty expensive, but they're also pretty reliable and available. What we also need in the production environment is, as I said, fine-grained security, the ETL and workflow, because here we can refresh data once a day, once in a week, should be okay. But when you are in production and you want to be predictive and real-time, then you would like to make sure that the data comes to your Hadoop cluster, as soon as possible. And of course, when you say that, well, Hadoop is the place where I save all my enterprise data in the form of data lake, then the things like disaster recovery and those things become very, very important. So all these things we are still discovering. I think today with the announcement of HDP 2.1, we hope that we can find answers to many of these questions. Now, real time. So this really previous part of my presentation talked about the predictive. How do we build the predictive models and how we can deploy them? Now, real time is another aspect. We have done very little work so far. But what we concluded in our exploration of past 1 year that Hadoop is primarily a batch processing platform. Originally, it has not been designed for real-time analytics. So if you create something on Hadoop, some model, and if you need real-time performance, then probably Hadoop is not the right place to deploy it. We built a model to predict the balance in your account over 30 days. And we could do that on Hadoop, but we realized that when we have to do it for 8 million people, then it takes a lot of time to calculate it. And by the time you are done, the forecast is very old because you went to a supermarket and you spent 50 euro or something like that. Also in the Hadoop world, we realized that there's nothing like real time. The real time is actually near real time or some kind of micro batches. So if you think that something is going to happen instantly, the moment my debit card goes in the ATM, followed by ATM, and immediately I'll come to know something, I can take action on it. That might not happen. So we are still busy with the evaluation of technologies, and I think very exciting thing is that now Apache Storm is part of Hadoop distribution, and also the Spark and InfoStreams. These are also two quite promising technologies. And I think the only way to learn about them is to play with them, and then we know that what's going to really work for us. Now, brief information about business cases. Unfortunately, I can't tell you a lot about them because of all the concerns and everything. I think first of all, we have created some models to predict mortgage defaulters. So before you really run into the financial problems and then bank calls you that you did not pay your mortgage installment last month, we would like to know that much in advance. So it's something like this, that you take around 130 variables about a customer, and you take them through a model, and then model can give you a score, and then you can predict whether this guy is going to end up in financial problems or not. Second is that we also use it for improving the segmentation in the marketing. So far, the models are pretty much based upon the structured data which we have in our enterprise systems. And we can also use it for improving the segmentation in the marketing. And last thing is that we can predict something for you. So if you look at these three use cases, they pretty much cover what we would like to do with Hadoop. The number one is related to reducing the risk for the bank. Number two is related to increasing the revenue for the bank. And number three is related to increasing the customer intimacy or being more customer-centric, helping your customers. So these are the three use cases. And if you look at our conclusions about Hadoop so far, is that it's a great technology, and it can really save us a lot of cost. It can work very well as a data hub or enterprise memory. The good thing about Hadoop is that you can load files in it without thinking about the schema and so on. You just load everything, whatever you have, just load it on Hadoop. And when you really want to use that information, then you think about the schema. That's quite different from what we are having now in our current ETL pipeline. When the data comes, then we really need to know that how this data is going to be loaded in our data warehouse. Also, surprisingly enough, we load the data in data warehouse by finding right fields and so on in a proper model. But all those files, we also back them up in tape. So somehow, by storing all those raw files, we have become one of the biggest users of tape storage in the bank. And that also costs a lot of money. So we feel that if you have HDFS, you just load your files there, and then you can cut down a lot of cost over there. It's cheap, reliable storage. It's fault tolerant. And because of it is open source, you can save significant amount of money in the license and hardware cost. The second benefit of the Hadoop could be that past 1 year, I would say that we have learned a lot. Last year, February, we did not know anything about Hadoop. And this year, we have got maybe 30 people in the company that know Hadoop quite well. And what we found that Hadoop is really ready for early adopters. It can save you a lot of cost, and it can accelerate predictive analytics in your company. Today, in the keynote, I saw that from early adopters, it has moved to chasm and to early majority, which could be the case, I think, with the new announcements. The challenge with Hadoop is that it is not a complete solution. It's a kind of a toolbox. And it is not going to solve all your problems. You have to be very, very active in the community to figure out how you are going to use it, what are the new tools coming up. And for every problem, you have got 3 or 4 competing technologies. And then you have to pick the right one. And then also you have to be prepared that very soon something new comes up, and then you're not going to use it. You will take a new one. The, what worked very well for us that we did business case-driven experimentation. So we did not do any kind of pure technical exploration. Huh? So when we set up our playground, the play environment in the beginning, at that time also we had a couple of business problems. Huh? So we said, okay, let's take those business problems, load data in the cluster, then start experimenting with it. Huh? And the good thing was that every 3 weeks when we were doing demo, we could invite business people and they would see the real results, and that really helped. And the last thing, which I will strongly advise to everybody, that this is really changing very, very fast. Huh? So you have to really create very good link with the community. We always favored that when we are implementing Hadoop here, then we would like to talk to those people who are committers, who are closely involved with Hadoop projects. Because that's the only way to sort out the problems pretty quickly if something really goes wrong. And it can also help you shape the roadmap of Hadoop. So this was my talk. If you want to connect with me, these are my details. And I'm open for the questions now. Yes, sir.
Do you use any new data sources for this, or internal or external, than you have used before?
So the question is that if we would use any new data sources, internal or external, right? So far, no. So far, we have just taken the data which was already available in our data warehouse, and we loaded it on Hadoop, and now we are playing with it. Yeah, we would like to do that. Sorry? No, no public data so far. No. Yes?
You talked about lower cost. Like, do you have a factor like lower, how much lower?
See, one number that I gave you was very much related to the Netezza versus Hadoop. So Netezza is typically, if you just look at the cost of buying the storage, it's around 15 to 16,000 euro per terabyte. If you are talking about Hadoop, then it could be 1,500 to 2,000 euro per terabyte. Huh? Yeah. You can't, yeah. You can't, but I think it's like this. Huh? If you have just data to store, then the question is that where do you want to really store it? Yeah. Now, I think that if you look at Netezza, it is expensive storage, but it is also a very fast appliance, right? So if it is a very fast appliance, then you have to really use it in a very, very good way. So we made sure that the data that we load on Netezza is really high quality data that needs to be queried near real time. Yeah? Yes, sir?
I can imagine that the use of open source software in a large bank caused some problems. Is that the case, and how did you overcome it?
I think first of all, I think the open source is also a kind of the little bit mindset problem because people think that by open source it means it's not secure and so on. I think what we have tried to do is that first of all, we created awareness, and there is a lot of support from the senior management about implementing open source in the bank for cost reduction and also because of the fast pace of innovation in this community. We have also tried to involve our people in these kind of community projects. And also, as I said here in my slides, that whenever we get the sources from open source, we scan them before they are really put in production. Yes?
Do you think, I would do a question like that's easy one, like when you set up those group of 30 people who are now experts in Hadoop, like did you use like official support or like commercial, or could you do it alone, just based on the community?
No, we could not do that alone. And I don't have 30 people. My target is to go up to 30 people. At this moment, I think there are 10 people who actually work on it. That's the Scrum team that really works on Hadoop. And yes, we took help of external expertise. They're part of my team, and that's how we could ramp it up.
Do you think these technologies get traction in banking applications? Because those are like, I work in both scenes or like areas, and it looks like it's that huge gap between the two things. So do you think it's going to stay marginal, or will it slowly flow into the like real-time transaction processing? Or
I don't know about all the banks, but I would say that in our case, the IT costs are a big issue. We have to do serious reduction in IT costs. So we are looking into all the dimensions where we can reduce the IT costs. So open source technology that is good, available, reliable, I think we'll just go for it. For example, 5 years back, we were not using Tomcat and Apache, and now we run a lot of application on Tomcat and Apache. So I don't know if we have any other option but to go for it. Yes, sir?
You mentioned in the first part of the talk that you find it challenging to find the right resources. About the R language and the R studio expertise, do you find it more difficult or the same level of difficulty?
You mean finding those people very difficult?
Finding the right resources.
See, you should see like this. We have two worlds. The one world is very much SaaS focused, and they have been using SaaS for a very long time, and they are quite good at it. They're masters of it. So what you see is that if you ask these people to switch to R, then it's kind of hard. So how we did in our place is that we built a separate new team. And that team was open to the idea of using R. And to my big surprise, all the initial push in the area of data science came from the engineers. The people who were setting up Hadoop, they learned R and they started playing with it. And then slowly data science scientists, they joined and so on. Yes, sir?
How many people do you need to operate the cluster?
Oh, that's good. What do you mean by operate?
Daily operations like monitoring, issues, fixing, upgrades from time to time.
Okay. See, there's something you see like this. We have a team of 10 people, and we call it DevOps team. So in that team, we have got 5 data scientists and 5 engineers. In the engineers, we have a split. We have got dev engineers and ops engineers in the team. So typically, in a team, we have got 3 dev engineers and 2 ops engineers. So these 2 ops engineers are responsible for running the cluster. But they don't do everything because some of the things are also done by the central organization. So it's very hard to count them because that's a shared pool. Any other questions?
You showed us 3 use cases.
Yeah.
And is it possible to tell me something about which data you use for these use cases? What kind of data did you use?
Yeah. I think I have really run out of time. Can we do this discussion offline if it is possible? Right? Okay. Thank you very much. You are a wonderful audience.